And to run this transportation method of linear programming, you need to install the Excel solver. And if you want to understand the linear programming in general using Excel solver, you can click here to see my PowerPoint slides. How to install solver add-in in Excel, also you can click here to see it. Basically, you will see this add-in, solver add-in, and so solver add-in in this the analysis toolpack is given, and click OK. Then solver is installed in your Excel program. Okay. So linear programming transportation method. This transportation method is the special linear programming method, and there are two primary objectives of doing this. Either you want to seek to minimize the cost of shipping n unit to m destination, or seek to maximize profit of shipping n unit to m destination. Suppose you have two unit, two sources and 3 destination. So A, B, these are the two main sources, and 1 to 3, I'm sorry. 1 to 3 is the 3 destinations. So there are 6, transportation routes are here. And solver program will find out the optimum solution to minimize this, total transportation cost or maximize the total profit. So let's go to your D2L website again, and I will demonstrate the USA pharmaceutical company case. So click here to access your Excel template. Then you are able to see this Excel file, and click US pharmaceutical company tab. I also included a detailed explanation on this problem in chapter website. So if we want to know more detail after watching this video, you can go to the D2L and see my detailed explanation. Or other video clips are available here, so you can watch these videos too. Okay, suppose US pharmaceutical company has 4 factories here, Indianapolis to Atlanta, and supplying warehouses of 4 major customers, Columbus to Los Angeles. And management want to determine minimum cost shipping schedule. So we have 4 sources, 4 supplies, and 4 customers. Here warehouses. And there are factory supply. This means the supply availability of these 4 main factories. And this requirement, this indicate the customer or warehouse demands. So Columbus has 10 unit demands, and Los Angeles 9 unit. And Indianapolis has 15 unit to supply. That's the supply availability. And within this, table, this indicate the shipping cost per unit. So $25 here indicate cost to ship per unit from Indianapolis to Columbus. So and so on. And then you have to create this candidate solution table and cost calculation table in order to find out the Excel solver solution. So before we go to the Excel solver, let's create the candidate solution and cost calculation table, and this should be done. And first of all, you need to put the 0. So why I put 0? Because this is not yet determined. This table is basically about shipping unit. So we don't know how much shipping unit is the optimal to lead to, minimum total transportation cost. So we put 0 first, and this table will be used for Excel solver. And they find the optimum shipping unit. And this is the total supply. So we use the sum function, Excel sum function, to sum up each one. So Columbus received this supply, and St. Louis, Denver, and Los Angeles. Again, total shipped. Use the sum function. You sum up this Indianapolis all the way to Atlanta. Again, solve a program will use this table to find out optimum shipping unit. And this is the unit shipping cost. The cost calculation table, we have to set up cost shipping, shipping unit per shipping cost per unit times shipping unit. The cost times unit. That's your total cost for in each case. So that number will be changed after using the Excel solver. Then this is a final total cost. So you have to sum up of entire these cost. Okay, so we set up everything. So candidate solution and cost calculation table. Then now you go to the data tab and solver. So let's delete. These are set up already from previous practice. So I want to delete and show you from the beginning. Okay, set objective here. You have to select the target cell, which is a total cost cell, which is F21. Okay, that's your target cell. Then what to click? We have to click the minimum option because we want to minimize the total transportation cost. Okay, and here by changing via variable cells, here we have to select this candidate solution table B10 through E13. Because Excel solver will change this to find out the optimum solution. And here important thing is we need to set up two constraints in order to run this solver. Because this solver program, solver solution is based on the two constraints. First constraint is that total amount to ship should be equals our current customer or warehouse demands. Total amount to ship equals warehouse demands or customer demands. Right? This should be our first constraint. Click OK. Second constraint is that our capacity of manufacturing plant of this Indianapolis to Atlanta does not exceed factory supply availability. Okay? Sorry. So the capacity of a manufacturing plant does not exceed or less than equal to the factory supply reliability, factory supply availability. Okay? So that doesn't exceed our factory supply availability, and click OK. These two constraints must be set. The next, we select this option because it's non-negative. Make unconstrained variable non-negative because total transportation cost is non-negative. It's not negative. It should be positive. So we select this option and we click the simplex LP as a solving method. Then click solve. And they are finding the optimum solution. So you see that total cost is now given here. So keep solver solution and click OK. And as you see, they already provide the optimum shipping unit. That way they lead to the final total cost. This is the minimum, total cost. Okay, that's it. Thank you.